it's expected to go up to 175,000 exabytes by 2025. So there's a lot of information. It's structured, it's unstructured, and how do we manage all of it? And the answer to that is it's complicated. This is a slide from a talk called "The Big Data Ecosystem is Too Damn Big." It shows all of the different types of applications being used to manage this information, from storing it in infrastructure to analyzing it with analytics. Lots of different tools. I'm not going to talk about any of these. One way to simplify them is using something called the 3 V's. Actually, people like adding more and more V's. It seems to be like the fun thing to do, but I'll just stick with the original 3, which are volume, velocity, and variety. So these are aspects of managing big data. So volume is the amount of data, velocity is the speed at which the data are coming in, and variety is all the different kinds of information that you have to deal with. And when you've got a problem that involves a lot of data that are coming in very quickly and are of lots of different sorts, you've got a big data problem. So now I'm going to talk a little bit about some of the areas in which big data have been applied to conservation. I'll talk about some of the work I did while at Google and where I was before WWF, and then I'll also talk about some WWF work. And I'll do it in the context of those 3 V's. So the first one is volume. One of the ways that conservation data are coming in large volumes is through satellite data. The UN agency that cares about such things recently reported that there are about 5,000 satellites circling around the planet. Of those, 2,000 are active and 3,000 are basically just junk. And of those 2,000, about 600 are Earth observation satellites collecting optical data, radar data, thermal data, all kinds of different kinds of information. And the question is, how do you manage all of that? And to answer that question, Google built something called Earth Engine. So Earth Engine is a tool to do analysis over large amounts of geospatial data. And the idea with Earth Engine was to take as much publicly available geospatial data as possible and aggregate it onto Google servers, and then provide a programming interface that lets people write their own analyses against the data. And those analyses happen in parallel over lots and lots of machines. But to analyze this, to use the system, all you need is a web browser, and then you get access to petabytes of geospatial data and the ability to analyze them over many, many machines. Google first applied the system on itself, which it likes to do, to create the base map for Google Maps and Google Earth. This was a big analysis. It's being updated regularly, and it involves petabytes of data primarily from the Landsat satellites and also the Copernicus satellites from the European Space Agency. The next thing that Earth Engine was used for was a project with Randy Sargent from Carnegie Mellon University, who took this idea of one global snapshot of the Earth and extended it to being multiple ones, one for every year since 1984, to create something called time-lapse. So you can go to earthengine.google.com/timelapse and see the change happening on the planet anywhere. And this is at Landsat scale resolution, so it's like 30-meter resolution. This was a very, very big analysis. And to give you a sense for it, here's some numbers. This is the first time we ran it. It was almost a petabyte of satellite data, and it took 2 million CPU hours. So if it was done on one CPU, like your computer under your desk, it would have taken centuries. But because it could run in parallel over lots and lots of machines, it only took about a day and a half. So this is an example of a system that's crunching these big data to provide these kinds of visualizations. The thing we really built Earth Engine for was for analysis. And the first conservation-focused one that we did was with Matt Hansen, who's a professor at University of Maryland now. And this was a study of forest change from 2000 to 2017. It was another big study. It's now using petabytes of data to show everywhere on the planet where forest loss has happened and when. And the nice thing about this application is it, along with lots of other kinds of forest data, were combined by a system called Global Forest Watch, which is convened by the World Resources Institute. And what they've done is taken the Matt Hansen data and lots of other data sets, combine them in a way that's usable by non-remote sensing experts to do analyses over the data. And this has had conservation impact. So for example, the Philippines House of Representatives used this information for policy on mangrove preservation. NGOs have been using it to act as watchdog groups. In one example, to monitor what should have been sustainably grown cocoa, but wasn't. So these are actual conservation impacts that these data are having. The next V I'll talk about is varieties. This is the different kinds of data. Satellite data is one way that people are using big data for conservation, but there are lots of others. So for instance, the Global Biodiversity Information Facility is aggregating lots of species observation data. They're up to 1 billion records. And this information is being combined with species range information, meteorological data, topological data, to do lots of analyses of species health by many different groups. So for instance, the Map of Life is taking all those sorts of data I just mentioned and combining them to provide reports on how well protected various species are. They're looking at, I think, 44,000 different species now, and they're showing trends of how well those are protected by existing protected areas. And those data are being reported to the IPBES, which is the UN's scientific body for reporting on global biodiversity health. Another kind of information that's coming in is camera trap data. There are lots and lots of camera traps taking millions and millions of images. And there's a system being developed now called Wildlife Insights to help aggregate all of those camera trap data. It's a collaboration of many organizations. WWF is involved, Conservation International, WCS, the Smithsonian, and several others are bringing together all of their camera trap data into a single system that will allow people to do analysis over all the camera trap locations. This isn't done yet. It's set to launch in 2019, and you can find out more at Wildlife Insights. Typing that into your favorite search engine. Another form of data that people are starting to work on is DNA analysis. So sometimes it's hard to look at, see a species in the field or even with a camera trap, but you can take samples of things like water bodies, like watering holes, and analyze the DNA in there to see what species have been there. This is an example from WWF of using DNA to identify polar bears and from DNA in their paw prints. So by sampling the paw print, in this example, they found a bear, a seal that it had been eating, and a seagull that was investigating. The third V I'll talk about is velocity. And I'm going to go back to forest monitoring. While we were working with Matt Hansen, his approach was sped up. Initially, it was doing annual reporting of forest loss, and recently he's been releasing weekly forest deforestation alerts. And the way he's doing that is by taking satellite data in as it's coming, rapidly analyzing it, and then reporting on the results. These are weekly results, and there are other systems that are doing daily results. So this is taking advantage of the speed at which data are coming in. Another example is Global Fishing Watch. So this is a system that uses AIS data, which is a signal mandated for large fishing vessels to show where they are. It aggregates all that data and presents it and also analyzes it. It's about 22 million data points a day, something like that. And these systems, these data are all going to Global Fishing Watch, and they're being analyzed with machine learning to identify for each ship when it's fishing and when it's not fishing, and to send out an alert if it's fishing in a protected area. So this is a good example of using artificial intelligence with big data. The Wildlife Insights platform, which I mentioned earlier, is also using machine learning to help identify the images as they're uploaded to the system. So another theme that goes throughout big data is using artificial intelligence to help manage all of the data. WWF is also working on a platform that's like Global Fishing Watch. This one is more oriented towards fishing fleets that want to add transparency to their systems. So it's a kind of a voluntary platform. So I'm going to end there with just some future directions. One big change that's happening is the amount of real-time data that are available. The IDC report that I talked about, that talked about how much data we're going to have in 2025, estimated that by then 30% of data will be real-time. So building systems in conservation that deal with that will be a good place to go. We're doing a pretty good job at monitoring, but one place that I think a lot of future work will go is in predicting. So trying to figure out in an actionable way where conservation impacts are going to be had, and doing something about it earlier. And then finally, there's more and more satellites, sensors going up of different forms. So we're going to be kept busy for quite a while, just dealing with all the new data that are coming in, plus trying to figure out how to work across multiple sensors. And with that, I'll end. Thanks a lot.
Thanks so much for the introduction, Thau. That was fascinating. There were some projects in there I hadn't heard about particularly.